The farther we venture into deep space, the more the universe seems to fight back. For decades, humanity dreamed of reaching distant stars and settling new, untouched worlds. We envisioned sleek starships gliding effortlessly across the dark, peaceful ocean of the cosmos. But recent astrophysical breakthroughs in 2026 revealed a terrifying new reality.
Interstellar travel is not just difficult, it is rapidly becoming exponentially more dangerous.
The threat does not come from hostile alien life, but from raw physical law.
Today, we dive 12 light-years deep into these newly discovered cosmic hazards.
We will examine what stands between us and our ultimate dream of cosmic survival. Before we can cross the interstellar void, we must understand why space is changing. Every scientific probe sent into the dark returns with increasingly unsettling data streams. The peaceful void we once imagined is actually an unforgiving, high-energy battlefield. Consider the dust problem, an invisible lethal barrier waiting in deep space. At rest, a microscopic speck of space dust is completely harmless and unnoticed. However, traveling at 10% the speed of light changes physics entirely.
At relativistic speeds, a single speck carries the kinetic energy of a bomb.
When a millimeter-wide dust grain strikes metal, it instantly vaporizes hull material. The collision releases massive plasma bursts, ripping catastrophic holes through vital hull structure. The faster a starship accelerates, the harder and more frequent these impacts become. Interstellar space is filled with billions of these microscopic orbital hazards everywhere.
Traditional titanium armor offers zero defense against kinetic impacts of this scale.
To protect human passengers, engineers must design completely revolutionary particle shields. Deflector fields and forward laser sweep systems are currently being tested in simulations.
Yet even a localized energy shield consumes unimaginable amounts of ship power continuously.
If a single microscopic grain breaches the shield grid, destruction is nearly instantaneous. This micro-dust barrier makes fast interstellar travel a high-risk Russian roulette.
Until shield technology advances dramatically, high-speed travel remains a fatal proposition.
Beyond physical kinetic debris lies another invisible killer, unrelenting galactic cosmic radiation.
Within our solar system, Earth's powerful magnetic field shields life from solar wind. Even deep space inside the heliosphere receives mild protection from solar magnetic forces. Once a vessel steps beyond the heliopause, all natural magnetic protection disappears. High-energy cosmic rays storm through interstellar space from ancient supernova explosions. Relativistic solar particle flares and gamma-ray bursts continuously bombard open interstellar space.
For a crew on a 20-year voyage, radiation exposure causes lethal DNA destruction. Human organs and electronic brain systems fail rapidly under continuous heavy radiation bombardment.
To survive, a starship would require 2 meters of solid lead shielding around it.
Alternatively, massive tanks of dense liquid water could absorb incoming cosmic radiation streams.
However, adding thousands of tons of heavy shielding makes spacecraft impossible to launch.
The rocket equation dictates that heavier ships require exponential amounts of additional fuel.
Active magnetic energy shields could deflect charged particles, but require compact fusion reactors. Until we harness ultra-dense power sources, deep space radiation remains entirely deadly. Our bodies remain fragile biological vessels, ill-adapted to the harsh interstellar radiation environment.
Distance introduces a psychological and technical nightmare known as the deep cosmic void. Our nearest neighboring star system, Alpha Centauri, sits 4.2 light-years away. Even at half the speed of light, a round trip takes nearly 2 decades. 9 full years spent trapped inside a metal capsule, completely isolated from humanity. There will be no emergency rescue missions, no spare parts, and 0 resupply ships.
The psychological strain of extreme isolation creates severe cognitive breakdown in closed environments. Every life support system, oxygen recycler, and water filter must function flawlessly for decades.
A single mechanical failure in deep space means absolute and unavoidable permanent failure. Closed-loop ecological systems frequently suffer toxic bacterial blooms and nutrient degradation over time. Cracks in stress points from continuous thermal strain can compromise structural integrity silently.
Astronauts must become their own doctors, engineers, scientists, and psychological counselors simultaneously.
The void does not offer second chances or room for human emotional mistakes.
To embark on such a journey requires accepting absolute detachment from Mother Earth.
Time itself becomes a relentless enemy, ticking away inside the cold, silent metal corridor. Beyond dust and radiation, humanity faces vast, uncharted mysteries in interstellar space. We have never directly observed the deep interstellar medium up close until recently. Dense, dark matter clouds drift invisibly between stellar systems, warping local gravity grids. Rogue planets, cast out from young solar systems, roam silently without light or warnings. Turbulent magnetic superstorms generated by distant pulsars sweep across light years unexpectedly. New data from distant space probes show interstellar space is far more dynamic and turbulent.
What we once thought was empty space is filled with complex plasma turbulence structures. Navigating these uncharted oceanic cosmic currents is like sailing blindly through violent storms.
Every deep space probe discovery reveals 3 new unexpected hazards we must overcome. Instrument sensors struggle to detect cold, dark masses until a vessel gets too close. Microgravitational distortions can throw a craft off course by millions of miles. Subatomic particle clouds can strip electrical charges directly from ship hull systems. We are attempting to navigate a galactic ocean using incomplete ancient maps. Respecting these cosmic unknowns is essential if we wish to survive beyond our sun. Without detailed reconnaissance, sending manned vessels forward remains an extraordinary risk.
Can humanity solve these monumental engineering challenges and conquer the deep void? The answer is yes, but not through massive single-generational starships.
Instead of giant, fragile vessels, scientists propose launching swarms of miniature probes. Ultra-light chip-scale spacecraft,
attached to gigawatt laser sails, can accelerate rapidly. Phased array lasers firing from Earth orbit push light sails up to relativistic speeds.
Thousands of tiny robotic probes form distributed sensor networks across vast space spans.
If dozens of probes are destroyed by microdust, the remaining thousands survive.
Advanced artificial intelligence systems will pilot these probes and repair systems autonomously. Self-repairing nanotech materials can rebuild hull surfaces instantly after particle impacts.
By shifting our focus from rapid human travel to patient robotic exploration, risks drop. We do not need to hurry blindly into the deep, dark space environment. We must proceed with extreme intelligence, calculated precision, and unprecedented patience.
So why is interstellar travel becoming more dangerous in our modern understanding?
Because our scientific knowledge has grown, revealing the harsh reality of deep space.
Space is not a peaceful void, but an active, powerful cosmic environment.
Yet heightened danger does not mean our ultimate interstellar dream is impossible. It simply means humanity must be wiser, tougher, and far better prepared. If you could launch a probe to another star, which system would you explore? Subscribe for daily science updates, because the stars are far, but not forever.